Hey everyone, welcome to our video. Today we will discover the magic of Sputnik1, the first space satellite, and further explore one main material that was found in the spacecraft and all around us today. In the late 1950s, a conflict between the United States and the Soviet Union began, known as the Cold War. In the midst of this conflict, the two countries were competing for superiority, which led to an interest in space exploration. On October 4th, 1957, the USSR launched their first satellite, Sputnik1, which successfully orbited around the Earth. This was the start of the space race. Sputnik1 was a simple ball-shaped satellite made of aluminum that was only 22.8 inches in diameter and a mere 138.9 pounds. The top hemisphere contained two antennas with a spring that deployed them as soon as the satellite was released from its rocket. The inside of the satellite was equipped with a radio transmitter, a power supply system made of 3 silver zinc batteries, a remote switch, a thermal system fan, a dual sequencer switch, a thermal control system, and finally a barometric switch. The satellite functioned by first having it filled with nitrogen until reaching an internal pressure of 1.3 atmospheres. Then power could be supplied to the radio transmitter and thermal control systems. Those then turn on the remote switch. At the right time, this process activates a sensor which separated the satellite.
This scanning electron microscope image shows aluminum at 8,000, 12,000, and 20,000 revolutions per minute by focusing an electron beam over the surface of the material to create an image. This image is largely magnified but is still able to maintain a high-quality resolution as seen in figures A, B, and C. It was composed of an aluminum body with nitrogen gas in its inner chamber. Over time, titanium has replaced aluminum in the creation of some aerospace equipment, including rockets and satellites. Other composite materials and alloys have been included in more recent production of satellites as well, including nickel-cadmium and aluminum beryllium. Compared to aluminum alloy, magnesium alloy is a lighter and stronger material. It is also much more workable under heat and pressure. In the future, aluminum will likely be a major material comprising fuel cell-powered aircraft, cars, trains, and other vehicles used for everyday transportation. It is the 13th element in the periodic table and has an atomic mass of 26.98 grams per mole. It is lightweight and has a density of 2.7 grams per milliliter. Aluminum can sink in water but still exhibit a lightweight quality, which makes the material very versatile in its uses. Aluminum also has a high level of reactivity with air. Due to this reactivity, a thin layer of oxide can form on the surface of the material to protect the layers of aluminum underneath. Some common objects that contain aluminum include flagpoles, car rims, cell phones, light bulbs, and many more.
So what's the origin of the name? It actually comes from a Latin word, alumen, meaning alum. The ancient Greeks and Romans used alum in medicine as an astringent and in dyeing processes. In 1761, de Morveau proposed the name alumen for the base in alum. In 1807, Davy proposed the name aluminum for the metal, which was undiscovered at the time, but agreed to use it. Shortly thereafter, the name aluminium was adopted by the IUPAC to conform with the IUM ending of most elements. Aluminium is the IUPAC spelling, therefore the international standard. Aluminium was also the expected spelling in the US until 1925, at which time the American Chemical Society decided to revert back to aluminum, and to this day, Americans still refer to aluminium as aluminum. The first step in the commercial production of aluminum is the separation of aluminum oxide from the iron oxide in bauxite. This is accomplished using a technique developed by Carl Joseph Bayer, an Austrian chemist in 1888. In the Bayer process, bauxite is mixed with caustic soda or sodium hydroxide and heated under pressure. The sodium hydroxide dissolves the aluminum oxide, forming sodium aluminate. The iron oxide remains solid and is separated by filtration. Finally, aluminum hydroxide introduced to the liquid sodium aluminate causes aluminum oxide to precipitate out or come out of the solution as a solid. These crystals are washed and heated to get rid of the water. The result is the pure aluminum oxide, which is a fine white powder also known as alumina. So what are the applications of aluminum? It is often used as an alloy because aluminum itself is not particularly that strong. Alloys with copper, manganese, magnesium, and silicon are lightweight, but they're very strong. They are very important in the construction of airplanes and other forms of transport.
Aluminum is a good electrical conductor and is often used in electrical transmission lines. It is cheaper than copper and weight for weight is almost twice as good of a conductor. When evaporated in a vacuum, aluminum forms a highly reflective coating for both light and heat. It does not deteriorate like a silver coating would. These aluminum coatings have many uses, including telescope mirrors, decorative paper, packages, and toys. Aluminum has a major impact on the industry with a contribution of $174 billion to the U.S. economy, making up about 1% of the annual GDP. Aluminum has also created more jobs in the American market through the production of primary and secondary products made of aluminum, such as the production of sheet, plate, and foil products, as well as transportation vehicles. Aluminum has also geared entrepreneurs into choosing it as a sustainable material for the production of products. Although a lot of energy is used in refining the aluminum, it can be indefinitely recycled if uncontaminated.
However, unfortunately, some of the aluminum products get lost in the landfills, making it harder to recycle, so just make sure to recycle your aluminum products. Aluminum is rarely found on Earth in its free form and is an extremely reactive element. It is globally the most used metal that does not contain iron. Aluminum naturally generates a protective oxide coating and is a highly corrosive resistant. Lastly, aluminum is the most commonly used material in major power transmission lines and is 100% recyclable with no downgrading of its qualities.
Finally, if you would like to learn more about what we talked about today, please visit these websites. Thanks for watching! We hope that you enjoyed our video and found it helpful.